we have another 5 weeks, 5 weeks to go, and then now we are currently in week 9. Okay, so today we are going to finish for the clustering. ISP. We are going to finish clustering, and then next week topic for association for 2 weeks, and then within week 12 we are going to wrap up. Week 13 and 14 will be on the group. Okay, so if I may recall, let's have a look at this. Okay. So last 2 weeks, yes, what we have gone through is on the clustering method, and then we have go through the dissimilarity, and how we look at the objects and then determine whether the objects belongs to or similar to the objects, either other objects in the data set. Okay, and then if it is similar, then we can put it into the same cluster. Okay, that will be the concept of clustering itself. And then we have gone through one of the algorithms. If I may recall, if you can what we call, okay, so if we look at the dissimilarity, right? So dissimilarity would be based on how we calculate the dissimilarity of the objects. What will be the main reference? Any idea? So it is depending on the data type, Okay, right, how many data type? For example, firstly we look at apa dia? Data type. The first data type, it will be
integer.
Okay, integer also can. So we have integer, which is actually we call it as apa dia?
Numerical.
Numeric, Then we have nominal. Okay, so nominal we have simple matching. Okay, and then we have another type of data, which is what we call asymmetry. Okay, so asymmetry here is the distance of object I and J equal to number of attributes, nominal attributes, minus of number of matching, divide by P. Okay, and then we have another one would be binary. Okay, so when you look at the binary, which we have to do firstly is the contingency table. Okay, and then you have to find the dissimilarity equal to apa dia? The distance of S and P R S T. Okay, so R plus P R S T. So R plus S divided by total of PRS. P plus R plus S. Okay, so this is for binary, binary. So so sorry yang ini. Okay, so ni adalah bawa ke sini make use of asymmetry. Okay, So there is a simple matching, and then you, if there is more than one nominal, more than one nominal attributes, then you have to use P minus M divided by P. And then when the data or the data type is a binary, right? So you have to look whether it's a asymmetry or symmetry. If it's asymmetry, then you are going to apply this formula. Okay. Right. And then okay, and then we have another one which is just now. Okay, we have gone through to the nominal. Okay, nominal. So, which is discrete. Okay. And then we have tadi apa nama, what we call binary. Okay, right. So and then we have what we call numeric just now. Yeah. So for numeric, how do you get the formula? How do you get the dissimilarity? How do you get the dissimilarity? Apa dia?
Measure the distance.
Okay, semua kena measure the distance lah. Tapi dalam numeric kita gunakan apa? We are using, pernah dengar tak? Which is known as Euclidean distance. Okay, Euclidean distance, which is depending on the how many attribute do you have in the data set. Okay, I is object I and J is object J, which is, for example, you have two attributes. Yeah, so the distance is equivalent to x of I minus the value of x of J power 2 plus apa dia? For example, we have y.
yi.
Yes, good. Thank you. Yi minus the yg power 2, and all will be the square root. Okay. In case you have three attributes, yeah, x, y, z. So means that I minus xj power 2 plus yi minus yj power 2 plus zi minus zj, yeah, power 2, and all will be, the summation will be the square root, yeah, will be square root. Okay, so this is would be Euclidean distance. Okay, so there are other, yeah, like you see in the notes, which is Minkowski, okay, and also Manhattan, okay, which Manhattan, which is which are this function using the same norm, yeah. It's just Minkowski using apa nama absolute, yeah, and then Manhattan focus on certain value lah. Okay. Okay. Just now for under nominal, we have discrete, we have binary, and the other one we have what we call OD, yeah, ordinal. So when you have ordinal means that you have rank, yeah, you have rank, and then this data or this variable will be presented as or transformed into numerical, yeah, and into numerical, and the distance of each object, yeah, in ordinal data set will be calculated using the Euclidean distance. So ordinal will involve some kind of first is transformation, and then also representation method, representation methods into numeric, and this one will be using Euclidean distance. So please bear in your mind, which is ordinal is actually considered from nominal data set, but the calculation of distance will be using numeric because of the process of this. Yeah. Okay, and then another thing would be using when the data would be in the form of vectors. Yeah, it can be presented as vectors, such as we have textual data. Yeah, so if you have textual data, yeah, if you remember, means that you firstly have to come up with what we call term frequency table. Okay, and then after you have the term frequency table, you can use the cosine. Yeah, so this will be using cosine similarity. Yeah, similarity, which is the um, the product of the term. Yeah, product means that referring to the term, the count of the frequency of each terms. Yeah, will be times to itself ataupun multiply by itself, and then it will be divided in to the combination of that terms. Yeah, if you gone through to this, oh okay, this one is k-means lah. Yeah, so this, if you go through to the previous slide on the similarity, you can have a check on that. Okay, and then what we have gone through will be the clustering algorithm, which is plus partitioning. Yeah, so the concept of partitioning means that we are dividing the data into non-overlap. So non-overlap, if you look at the clustering algorithm, is actually a concept of putting much effort in terms of determining how many clusters will be appropriate for this data set. So the data will be partitioned into K, and then you have to decide how many cluster, yeah, that you want to create or you want to have in the data set. Okay, for example, here you want to partition the data into 2 clusters. Yeah, so initially when you divide data into 2 clusters, what you have to do is to identify or to initialize the centroid, yeah, of these 2 clusters, and this the centroid will be the center point, yeah, the center point of reference. Yeah, so each object in the data set will be calculated. Yeah, it means that the distance of each object in the data set will be calculated based on this distance to the centroid. Means that if you have 10 objects, each of the 10 object will be need to you need to get the distance of object to centroid 1, okay, and object of centroid 1 object 1 to centroid 2. Okay, and then the assignment of the cluster would be the most atau the nearest. Okay, says that object 1 nearer to the cluster centroid 1, so it will be assigned as cluster 1. Okay, and then next is will iterate to the second object, third object, and so forth. And finally, after you finish the iteration, yeah, you will see a group of cluster, yeah, being allocated, being assigned, yeah, to the nearest centroid. So like this one, okay. After we have this, yeah, after we have the assignments of 2 cluster, then the algorithms need to update a new centroid like this one. Yeah, originally they are originally the assignment is to this centroid. So when you have when the algorithm already update the cluster into 2, so it need to recalculate, and algorithm will gain a new mean value for each cluster. Okay, so this is will be it will goes to the second iteration with 2 new centroid. Okay, and then it will be repeated, right? And then each of the objects in the data set will be calculated. Yeah, the distance of the each object will be calculated based on these 2 new centroid. Okay, and as you see here, this will be the updated cluster. Yeah, objects. What are the objects in each cluster? And then it will iterate, and so forth. So have you done this part? Dah cuba belum? Hmm? Hello?
Belum, madam.
Belum buat? Belum cuba? Yang lain ada yang dah buat?
Belum.
Kenapa belum buat? Huh? Okay, so hopefully you have to try this one. And don't wait for I don't think that we managed to go it detailed one by one. So I also have given you the exercises. Hope that you have gone through it. So this will be the process of clustering. It's similar to what we see in the previous slide. Okay. Okay, means that you have to calculate this is X, Y, and then this is referring to the attributes. Yeah, this is the attributes. Okay, and then this will be the objects. Okay, and then how to get the distance of each object. Yeah, so this will be the apa nama? I mean before that this is the assignment of the centroid. If you look at this is assignment of a centroid. For example, we want to get the distance, so we use what? We use Euclidean distance. Yeah. Kenapa kita guna Euclidean distance? Why use Euclidean distance?
Numerical.
Yeah, because it's numerical. So as you see that this is 2, this is 6. Yeah. Okay, and then you have to calculate what is the distance of
And let's start.
Right. Alright. Okay, so this part boleh boleh dapat, boleh faham?
Boleh.
Yeah. Okay, so what you can see next would be this is the calculation of each, yeah. This is calculation of the distance each of the object to the centroid, yeah. So that's why when it goes to distance of to the centroid y is near closer, then it will be assigned to cluster 1. So this is all objects under cluster 1, and these are all objects under cluster 2. So after that, when we go to the second iteration, okay, so we will look at what will be the new centroid for each cluster. Okay, so here the updated value for the new centroid. Yeah, how do you get 2 plus 3 plus 3 plus 4? Macam mana you dapat ni? How we get this one?
Ikut dia dekat cluster mana.
Okay, 2 plus 3 plus 3 ni kita dapat daripada mana? This one. Value ni dapat daripada mana?
The X value.
Data 1, 2, 3 and 4.
Yeah, thank you. X value of the data 1, 2, 3 and 4. This is the X value, yeah. Attribute X, 2 plus 3 plus 3 plus 4. And then we have 4 object, then we divide into 4. So we will get a new mean, okay, for cluster 1. Okay, and this is will be the X. Okay. And meanwhile, if you look at apa nama? Okay. If you look at okay, if you look at second cluster, this will be the X value. Okay, so 6 plus 6 plus 7 plus 7 plus 8 plus 7. Okay, and then we have 6 object when we divide into 6 object. Meanwhile, the Y value will be 2 plus 4 plus 3 plus 4 plus 5 plus 6. Okay, and then this will be divided into 6. Okay, so you will get what we call here the mean value for Y is 4. Okay, boleh faham? Okay. Okay, thank you. So next we go to this is another I mean after we have this, yeah, after we have this one, yeah, then we will recalculate the distance of the object to this new centroid, and it will be repeated. Okay, it will be repeated until if you see after a certain iteration says that, yeah, says that this object maintained in cluster 1, cluster 1, cluster 1, 1, 1, and 1. Okay, and then this is 2, 2, 2, 2. Yes, after certain iteration, it maintained in this cluster, so it will be terminated. Yeah. Okay, so please have a look at this one. This is a discussion of the k-means, yeah, itself. Okay, so this will be the algorithms of the k-means. Okay, so now if you look at the methods of k-means, at the end your data will be partitioned, yeah, partitioned into the clusters, number of clusters that we have assigned initially. Okay, how about class C and A? Have you done the exercises given to you? Have you done the exercises given to you yesterday? Dah buat belum? Ke belum buat? Semalam public holiday, so tak buat. Ya? Hello? Ya ke?
Saya tak buat. Kakak saya buat kot.
Alright, tak apa. Buat nanti ya. Okay, so today what we are going to look will be on the hierarchical. So this will be another methods in clustering. Okay, it's considered as classical methods. Yeah, definitely we have to go through the classical methods before we go to the advanced method. Yeah, so the classical hierarchical will be slightly different because the target what we want to produce is all objects will be in the same cluster. That will be the target. Okay, but at the beginning definitely we will look at pairs of objects, and if the pairs of object is similar or closest, yeah, to each other, it will be merged. Okay, and in term of putting it into one big cluster at the end, what we could produce will be the dendrogram. So it's actually if that's why it's been called as the hierarchical, because we can see that this will be the most similar clusters, objects in the clusters, and then this will be the second similar. Okay, and then if you look at after this process, okay, this will be the third similar, yeah, objects, right? and then finally we would have this object combined together. Okay, at the end, if you look at this, would be the last, yeah, this would be the last object similar to other cluster. Okay, in dendrogram, yeah, this is what we producing, yeah, sorry, this is what we call as dendrogram. Okay, and then this one kita panggil apa? Any idea?
Venn diagram.
Okay, Venn diagram. Okay, so this is what called as the nested cluster. Yeah. Okay. Yeah. If you see that there is a cluster, and then there will be some of bigger cluster, yeah, outside of the boundary. Okay. So how hierarchical cluster be done is that ataupun there are two actually before we go there how it been done. Okay, there are two types of hierarchical clustering, yeah, which is ADNES, is a short form for agglomerative. Yeah, it will start with single object as a own cluster, means that object A is belong to cluster 1, object B is belong to cluster 2, object C is belong to cluster C. So each object is actually one cluster. Okay, and then at the end, each of the object is actually belong to one big cluster. Okay, saya tutup saya tutup saya punya kamera because too slow, my internet is too slow. Okay, and comparatively to diversive is Diana, yeah, which is or the short form is known as Diana. Diana will be act differently, means that from a big cluster, yeah, it will divide the data into different clusters. Yeah, at the end, each of the object will be belong to one cluster. Okay, so what we are going to discuss will be one of the methods. We are not going to cover all. Okay, one of the methods, which is agglomerative or ADNES. Okay, so agglomerative, this one is the same. Okay, so for agglomerative or under the hierarchical clustering, yeah, they method also, yeah, there are method also been applied, yeah, in putting the connection between the cluster, which is known as single link. Okay, but there are actually not only single bit link, there are many, yeah. Okay, let's go next. Okay, this will be the steps of the pseudocode of the algorithms. Okay, so firstly, what we need to do would be to find the dissimilarity matrix of the object. Do you have any problem to understand this part? Do you have any problem to understand this part? What is the meaning of compute the dissimilarity matrix? It's referred to what? To what process? Dia refer pada proses apa? Any idea? Proses yang mana ni? Okay, this refer to the process that I mentioned earlier before, which is we are looking at what? We are looking at the data type, and then we look at appropriate formula to calculate the distance of each object. Okay, and then you are going to come up with the dissimilarity matrix. If you remember what is dissimilarity matrix, dissimilarity matrix is referring to the distance of this is object apa nama P1, P2, P3. Okay, and then we have here P1, P2, P3, right? Apakah value di sini? So the distance P1 dengan P1 definitely akan jadi apa? Berapa? Distance P1 dengan P1. Distance antara U dengan U.
P1.
Zero.
Kosong lah. Kan? Distance antara U dengan kawan U sendiri. Adakah sama? Tak ada beza lah. Sebab you are the same object. Okay, this one will be 0. But the distance of what you need to you get is antara objek 2 dan objek 1. Okay. So dekat sini you kena dapatkan dia punya dia punya distance di sini. Okay, so you need to identify, yeah, what will be the distance of P1 dengan P2? Yeah, so using the Euclidean distance, okay, says that they have X dengan Y, okay, X for each object ni dia ada X dengan Y value. Okay, so you need to use the Euclidean distance X1 minus X2 plus X1, X, apa nama, sorry saya cakap terbalik. X1 minus X2, okay, power 2 plus Y1 minus Y2 power 2 and then square root kan, and then you will get the distance of 2 dan 1. Understand? Okay, and then here it should be distance of object 3 and object apa? 3 and object apa? Okay, thank you. Right, and this one? Distance of object? 3 and 2. Yes, thank you. Okay, so this is the similarity matrix. Again, benda ni repeat benda yang sama. What you have done last 2 weeks, yeah, or what we have done in getting the dissimilarity matrix. Okay, clear about this one? This will be the first steps. Okay, and next, yeah, after you have get this one, what we are going to do is to merge two closest cluster. Remember just now I said that in agglomerative, firstly, each object consider one cluster. Means that here we have 3 objects. So this is cluster 1, this is cluster 2, and this is cluster 3. Okay, so that's why it's mentioned as clusters here. Okay, so merge the two closest cluster. Okay, so the algorithm will search in this table, okay, which will be the closest, yeah, closest cluster by looking at the distance. Yeah, so it will have to compare. There are 3 distant value. Which one will be the closest? Okay, imagine that. Right, for example, yeah, apa nama? Oh, sorry. Sekejap, tak terror lagi guna benda ni. Sekejap okay, imagine that we have one identified, Allah, tak bertukar juga. One have been identified as the closest, the most lowest. Yeah, so this will be the lowest. Okay, the lowest. So means that, yeah, means that merging process involve combining ataupun putting object 2 and object 3 into one cluster. Understand? Itu maksud proses kedua ni. You understand? Boleh faham? Okay, boleh faham? Can you understand? Okay, so now, okay, what you are going to have is that, okay, from 3 cluster, when you have merged two object, it become apa? So the number of cluster will be reduced into 2, isn't it? Betul tak? Tolong jawab. Betul. So what you need to do is that next you have to update. Okay, so from here you need to reconstruct a new dissimilarity matrix which consists, okay, P1 maintained in the own cluster, isn't it? And then we have P2 and P3 in another cluster, okay? And P1 and also P2 and P3 in the same cluster, okay? So currently we have cluster 1 and cluster 2. Cluster 1 and clusters 2. So this is 0, this is 0. And then you have to find a new distance value for this one. Okay. So the process will go through. So definitely at the end, if you see now, okay, there are no other object. Yeah, no other object, only this one. This will be definitely combined to one big cluster, which is you will get P1 lagi, P2 and P3, okay, and then you will have P1, okay, and P2 and P3, okay. So this will be definitely a 0 lah. Okay, so when you have finished ataupun you have got this one, means that the process will be terminated. No more looping. Okay, right? Do you clear about the process?
Yeah.
Okay, so this will be what we are going to do next. Yeah. Okay, so in dendrogram, at the end, if you see, yeah, after we have combined the objects in the data set, at the end it will be definitely creating one big okay, dendrogram itself. What I want you to understand, yeah, what is dendrogram here, yeah. Okay, so this is object 1, this is object 2 until object n. Betul tak? Okay. Okay, so object 1. P lah kita letak P O kosong. Okay, P1 until Pn. So this is a new cluster merge, cluster until so on. Okay, right. So dendrogram also have X and Y. Okay, so this is the X. Yeah, X is presenting object. Yeah, presenting object, and there is Y. So what do you think? What is Y? Apakah Y itu? What is the value of Y?
Cluster?
Belum lagi clusternya di sini. Ini cluster.
Oh,
Okay, ini satu cluster, ini another cluster. Okay, what do you think? What is Y? Kat sini tadi kita buat sesuatu. What do you think?
the level?
Level of what?
Level of
Merge.
the...
Okay, so if you remember just now, what we have gone through in the Dissimilarity Matrix, we look at object 1 and we have object 2 and we calculate something for object 1 and object 2 and this will be shown or represent that value. Apa value itu? What is the value? Yes, this distance means that this is presenting the distance of object, yeah, the object 1 and object 2 or object 1 and another cluster 1, one cluster to another cluster. Yeah, so this is a form another cluster. Okay, and then we have another object or another cluster. So this is the value. Okay, so this is dendrogram. Understand? Do you understand? Okay, so each of the axes, yeah, has a meaning, has information that we need to get or we extract from the Similarity Matrix. Yeah. Okay. So this is actually the illustration of the process. I think that this one I have to skip lah, yeah, because it's actually the repetition of the process just now that I has mentioned. You can go through later on, yeah. Okay, this one I want to go more specifically in terms of the distance, the calculation of distance. What you have heard, I continuously said, you have to merge, yeah, you have to merge the objects based on the minimum. Betul tak? Yeah, based on the closest distance. Okay, let's have a look at here. You could see another definition or another functions, yeah, for the similarity. Okay, mean actually, yeah, mean is actually an operator. Yeah, in this context, mean, max, group average, and so forth is actually operator. Operator of what? Okay, if you look at this one, okay, mean is actually finding, yeah, finding objects in cluster 1 and cluster 2, okay, which object between this cluster at the lowest or the minimum, yeah, minimum distance. Okay, this is will be referring to the mean. Okay, right? Okay, if you look at cluster 1, okay, okay, cluster 1 and clusters 2. It's not only this object, yeah, bukan objek ni sahaja dalam cluster. We have more. Okay, so what will be the functions of other object? Okay, so there will be a definition of finding similarity, not necessarily using the minimum distance ataupun mean operator, yeah. We can use to define clusters based on the factors. Okay, so this is a factors object. Yeah, so this can be presented and this can be calculated using maximum operator. Okay, boleh nampak beza the mean and the max? Can you see the difference? Boleh tak?
Yes.
Yes. Okay, how about group average? Aha, any idea? Mean. Okay, group average will be equivalent to mean. What does it mean? Mean. Di sini pula dia lebih kompleks yang mana dia pakai semua distance objects in both cluster. So, how to look at it? It will be like this, right? So, you need to, the algorithm need to calculate the distance each object, object 1 to object 1 in the cluster 1 as a second cluster, object 1 to object 2 in the second cluster, object 1 and object 3 in the cluster, and object 1 and object. So we need to calculate these distances, and we get the mean distance. Okay, we will get the mean distance. Okay, right? So the mean distance will be used as operator to determine the clusters. Okay, and how about the centroid? Ini replicate is like the one we have done before, which is looking at the centroid. So mean that here, we need to get the centroid, the centroid of the cluster, and we compare, the distance of centroid 1 and centroid 2. Okay, right? And it could be another functions as well here. Okay, let's have a look at here. Okay, so in the illustration is actually technically it shows only 2 cluster. But in the real case, you could have more clusters. Okay, so let me make it bigger here. Okay, so for example, this is cluster 1. Okay, cluster 2, and this is a lots of object, and then you have another cluster here, cluster 4. Okay, and then you could have here, yes, cluster 3. Okay, so you have to find, okay, let me put it like this. Okay, you need to find, cluster 1 can be merged with cluster 2, or cluster 1 can be merged to cluster 3. Okay, or cluster 1 can be merged to cluster 3. Okay, so for example, we are using operator mean. So mean akan cari mana? Katakan this is, let me padam sekejap. Tak boleh padam lah. So, tapi you imagine X1 ni adalah the apa nama? The object yang paling tepi lah, So, and then this will be another object here. Okay, so this is how it get the mean of, using the mean operator for cluster 1 and cluster 2. Okay, so for cluster 1 and cluster 3, it will find the object here. And then this one will be for cluster 4. Okay. Right. And then next, if we apply max. Kalau kita apply max, macam mana scenario dia? Any idea? Okay. So scenario, when we apply max, it could be like this here and here. Okay. And then here and here. Okay, faham tak? Lepas tu ini pun ke sini. Okay, boleh faham ke? Boleh faham ke scenario dia? How we use min, max. Ya, boleh faham eh?
Boleh.
Kejap.
Boleh.
Boleh ya? Okay. So next we are going to do the calculation. Okay. Right. I'm sorry. Okay. Oops, mana tadi? Okay. Right. So this is how we look at. Okay, now let's do the calculation. If you want to know, the distance, the distance of these two objects, okay. Let me give you example. This is between 3 and 6, and then so 3, 6 is actually cluster 1, and then 2, 5 is cluster 2. Okay, so how we know how we want to get the distance between cluster 1 and cluster 2. So this will be the the steps to calculate, which is we are using operator min, okay, and then distance 3 and 2, okay, it will be like this, 3 and 2 and 3 and 5, okay, and 6 and 2 and 6 and 5. So we elaborate the point inside the ataupun we elaborate the object inside the cluster. So how we get this? This is given in the Dissimilarity Matrix. Okay, and then distance between 3 and 2 is 0.15. You assume, and then distance 6, object 6 and 2 is 0.25, and then distance 3, 5 is 0.25, and 2, 3, 9. Yeah, and definitely the minimum will be ataupun the lowest will be 0.15. Okay, meanwhile when you use maximum, okay, so when you use maximum, the same, it's just that we change the operator here into max. Okay, so into max, then we will get distance object 6 and 5 will be the maximum, which is 0.39. Okay, so this is how we use we use min and max. Okay, what is min? Min can be can be referred to the single link, and max is referring to the complete link. Okay, right. So first here I want us to do this exercise for the min or single link. Okay, it using the basic algorithm just now. It's using the basic algorithm, and the most the closest point, the closest point will be used to determine the pair of ataupun merging process. Okay, given to you this one information, okay, and we have 6 objects, and the 6 object can be presented in the 2D space here like this, okay, and this will be the coordinates of each object. Okay, this will be numeric attribute. So first of all, what you have to do is to come up with the dissimilarity matrix of the object that we have in the data set, okay, using Euclidean distance. So I skip this one. So we have produced, this is what we call the dissimilarity matrix. Okay, right, now what we are going to do is that, to find the 2 closest clusters. Okay, from your view here, at this point, can you find any closest cluster? Can you give me the closest cluster from this dissimilarity matrix?
P2, P3.
Okay, thank you. Means that you identify.
P3, P6.
Okay, Irfan. Yes, betul. Maksudnya kita kena tengok lah yang mana satu paling rendah, which is you can see here. Betul tak? Okay, this one. Okay, But technically, in terms of we could see here there are another cluster will be close lowest also here, and it's not interrelated. Yeah. So what we can have here would be two closest clusters. Yeah. Okay. So after we have the two closest cluster ataupun two shortest distance, object can be formed, will be formed to the first two clusters. Okay, right? So here, what you see here, okay, 3 is combined with 6 and 2 is combined with 5. And remember, okay, you need to capture the value and it will be shown in the y-axis. Ini x, ini adalah y. So y is ataupun kita jangan letak xy lah. This is object. Okay, and this will be represented as this distance. Okay, so 3 and 6 is merged, are merged, and then the distance with 0.11. And then 2 and 5 are merged, yeah, with the distance of 0.24. What 0.14. Understand? Okay, this is step 1. Okay, so next, what you have to do? Apa dia? Next, what do you have to do?
Distance between
Update.
cluster.
Maksudnya sebelum kita calculate distance between cluster, kita kena update tadi. Siapa cakap Dayang
Saya.
Sorry, tak nampak nama tadi. Siapa saya tu?
Mardia.
Okay, thank you. Alright. So, selepas ini, steps 2 adalah, ya. Oh, dia tak nak bergerak. Sekejap. Next is update the matrix. Yeah, update the matrix. Yeah. So, we have combined 3 and 6. We have combined object 5 and object 2 into the same cluster. So we have to update the matrix. Yeah, what's the process of updating? Yeah, process of updating means that we have to look at the distance of cluster 1 to other object, which are object 1 and then cluster 1 with cluster 2 and then okay, other object as well here, and oops, ada lagi satu tertinggal which is inilah. Yeah, kena calculate juga. Yeah, what will be the distance of 3, 6 and object 4. Okay, right. So each of these need to be calculated. Okay, macam mana kita nak, how we want to get the new distance of this cluster. Okay, so we have to look at one by one. Okay, for example, here this is within saya tak ikut sequence. Easiest to say is that to look at by sequence means that here, yeah, how we get 0.24. Okay, this is cluster 2, 5 and object 1. Yeah, so distance of 2, 1. Yeah, macam mana kita nak extract, which is 2, 1 and then 5, 1. Okay, 2, 1 and distance of 5, 1. Okay, yang ini kita nak dapat dari mana? How do you get distance 2, 1 and object and also distance of object 5, 1? This part you have to refer to the previous matrix. Yeah. So due to the smaller the constraint of space, I do not put it in here. Okay, but you can make a reference to this one. Okay, so 2, 1 is 0.25 and then 5, 1 is 0.34. Okay, ingat right? So you can see, okay, 0.24 and 0.34. So remember we are using single link, so the operator is main. Yeah, the operator is main. So the distance between these two clusters is 0.224. Understand? So the 0.24 will be put here. Okay. Next, what we need to get is the cluster 3, 6, and object 1, which is here. Okay, so how we get the distance of these two cluster, yeah, 3, 1, and 6, 1. So what will be the minimum of distance 3, 1, and 6, 1? Okay, again, how do you get this? Please refer to the previous, yeah, this matrix in the first iteration. Okay, so the distance 3 and 1, object 3 and 1, yeah, will be 0.22, and then 6 and 1, 0.23. So we are using the mean, so a distance will be 0.22. Okay, and the rest. Okay, and the rest. So you have to get, this one is original. Kita tak buat apa-apa. There is no affected clusters. But this one is affected cluster. Yeah, there is affected cluster. So we have to look at here. Okay, this also, yeah, a new cluster form. So you need to get the value of this one. Yeah. Okay, any questions so far? How to get the distance? Any questions so far? Okay, boleh eh? Okay, so after we have update, tak ada soalan
Tak
Ada
ada,
soalan?
all good. Okay,
Tak ada,
Okay.
insyaAllah.
Okay, so next after we update, then we have to look at the Dissimilarity Matrix here. Okay, kita pun study lah. Okay, the algorithm need to study on the new produced the new produce here, and then which will be the closest ataupun the lowest distance will be merged, 0.15. Okay, so this cluster will be merged together with this one. Okay, so this one will be cluster 1, this will be cluster 2, will be a new cluster, and then this is cluster 3. Okay, so you will have only 3 clusters later on. Okay, so what we need to do is to update this matrix. Before that, definitely what we need to do is draw the dendrogram, because we have formed a new cluster here. This is C1, this is C2, and this is C3. Okay, right. So this is considered a C4, and this is considered as C. Okay. Next we have to update it. Okay, right, like this. Okay, and we have to find what is the new value for this one. The same process goes, like what we have done in the previous step, which is we need to get what will be the distance of the newly formed cluster with object 4 and the newly formed cluster to object 1. Okay, so how you get this? Okay, so 3, 6, and 4. Okay, 2, 5, and 4 distance. So we have compare between 3, 6, and 1, and 2, 5, and cluster 1. And again, we are using mean. So that's why here you get 0.16, and this one will be 0.2. So here you will replace with 0.16, and this one will be replaced to 0.22. Okay, all right. So which one will be the closest? Okay, this is the closest. So this cluster will be combined with this. Okay, so we can draw a new dendrogram like this. Okay, so updated now, we have C1, C2, and then we have C3, and then we have C4 here. Okay, right. Okay, from 3, now we have to update the matrix into 2 objects. Okay, so 2 objects finally, this one P1 and this cluster, and then you need to calculate the distance. Same process, then you will get 0.22 here and update, and then finally you will get here, you need to draw the dendrogram. Is there any more? No. Okay, there is no more object to be merged. Okay, then what we can do is that, yeah, we will terminate the process. Okay, boleh faham? Yeah, anything to ask?
Saya ada soalan, Madam.
Yeah.
Before step yang ni, ada step sebelum ni yang kita nak kira distance between 3, 6 dengan 1. Kan? Kalau
Betul.
dalam matrix tu macam mana nak tengok?
Kita kena tengok previous matrix. The previous matrix. Like, kan? Sekejap oh, saya dah pergi ke depan pula. Okay, next. Okay. Okay. So this is what you have to get. Okay, this is previous metric we already calculate, yeah. Distance object 4, katakan object 3 dengan object 1. Sorry kat sini lah object 1 dengan object 3. Kita dah tahu dah value dia berapa. So dia ada temp memory lah di sini, okay. And then object 3 and object 6, object 1 and object 6. So data ni ada, yeah. As I said just now here, okay, says that you want to get the distance of 3, 1 and 6, 1. So you have to make reference to the previous matrix. Boleh ke Daniel?
Boleh. Kalau maksudnya contoh kalau yang seterusnya kan lepas step ni, the next step yang kita dah ada 2 clusters. So kita join cluster yang P2 cluster yang tu dengan cluster yang the third one kan jadi mean distance 3-1 lepas tu dengan 1. So kat situ kita tengok from table yang kita create yang baru ni lah.
Yang previous one tu kan.
So
Okay.
each of the previous bukannya tengok daripada original sahajalah.
Yes.
Okay.
Dia kena tengok, katakan you dah masuk yang ini iteration 2 kan. So you tengok previous matrix. Okay, katakan yang ini you masuk kepada iteration 3. So you have to refer to the previous matrix in iteration.
Okay.
Alright.
Thank you.
Alright. Okay. So it's very important for us to understand the dia punya proses updating the matrix ni lah, yeah, because this information will be used for us to determine the distance itself. Okay. Right, so katakan let's see how the nested cluster been formed. Yeah, this will be illustration on that. Okay, firstly, as you see, object 3 and object 6 is been merged, and then object 2 and no, not yet. Okay, object 2 and 5 is been merged. Okay, and then object, laju lagi. Okay, and this object is been merged because it's closest compared to 1 and 4. Okay, right, and then the third cluster is merged with object 4, forming the fourth cluster, and finally forming the fifth cluster when all objects can be seen as one big cluster. Okay, and this will be the dendrogram. So pick the highest ataupun the one that we want to produce using cluster similarity will be similarity. So that's why this algorithm will be popular for determining objects like species, yeah. So we can see species 1 and species 2 similar, species 3 and species 4 similar to each other, yeah. Like lion, jaguar and lion, is it same? Something like that lah kan. So at the end, each of these is in the family of cat, yeah. Kalau kita tahu pun cat pun ada banyak jenis kan, ada banyak spesies apa? Stray cat, yeah, and then we have short, apa kata? Siapa boleh kucing? Short, apa? Short.
British
Ah,
short hair.
British short hair, and then apa lagi entah, ada banyak jenis jenis apa nama, jenis kucing lah kan. So this will be at the end, it can be combined into one cat lah, yeah, one group of species of cat, yeah. So this will be useful for us to look at the hierarchy lah, hierarchy of the objects, yeah. Okay. Okay. So now we are going to look at the second approach. Yeah, kita gunakan approach yang sama, but in the second method, second techniques. Yeah. So please bear in your mind. Okay, the merging process is always based on the minimum ataupun the closest. Yeah. Tetapi operator kita gunakan di sini kali ini kita gunakan max. What's the difference? What's the difference? Okay, let's have a look at it. Yeah. Okay. Firstly, the first step is same, means that we have to look at the object can be merged, yeah, two shortest distance, yeah, from the Designation Matrix or table. Okay, we could see that object 3 and also object 2 and 5 can be merged. Okay, so this would be normally step 1 when you apply maximum will be the same outcome ataupun output with previous method in min or singling. Yeah, so this will be the outcome there. Yeah, outcome iteration 1 or step 1. Yeah, when you use max and also when you use min will always the same. Normally sama lah, normally sama. Okay, okay, right. So next what you do is to update. Prosesnya sama juga. Next, you have to update the matrix. Okay, so when you update the matrix, you will see here. Okay, the difference is that the operator. Yeah, so here we use max. Okay, why max? Because just now, like we have object here, min is comparing objects that nearest, yeah, to each other. But now when you use max, we are comparing object farthest between this cluster. Okay, so this is 3, 6, yeah, and 2, 5, and then we have another object 1, and then we have another object 4. Okay, so this is what you have in this particular process, yeah. Okay, right. Dah habis. Okay, kejap Right. So this will be kejap nanti. Right, so after you have kejap. Okay, now okay, so now you have sorry, mana pen saya tadi? Okay, now you use max. So max, you have to operator max, then you have to find what will be the maximum distance. Okay, so that's why here we choose 0.39. Okay, right, and then here also we choose 0.23. Okay, kalau kita gunakan min, then it will choose the lowest. Okay, now that is the operator in calculating within the objects. Yeah. Okay, now when you choosing, yeah, again, where you want to choose which cluster can be merged, ini back to the rules of thumb, which you have to choose based on the closest ataupun the lowest. That's why 0.22 is been it's been chosen, yeah, and the cluster, the new cluster to will be formed is within 3, 6, and 4. Okay, let's have a look at it. Right. Okay, so here when you update the when this is the new matrix, updated matrix, Okay, and object 3, 6, and 4 is being chosen to be merged as a new cluster. Okay, kenapa? Why? Kenapa? Kenapa kita pilih yang ini? Why?
Sebab
Why?
between dua objek tu dia dekat.
Ataupun kita boleh kata because each give the lowest distance. Okay, boleh faham? Okay, because it give the lowest distance in the updated matrix. Boleh? Okay, now what we can do is that to form the, means that here we have chosen ini to be combined kan? Betul tak? Okay, next we have to form the cluster. Okay, we are going to form the cluster. Okay, and then we can draw a new dendrogram, yeah, between 3, 4 and also object 4 with the distance of 2, 2. Okay, right. So at the next iteration is that you will update, yeah, you will update the cluster, yeah, with these new objects. Okay, and again process need to get the new value for each of the object. So you will get, like, you will need to do it again, and it will be updated. Okay, and we choose this one because it shows the lowest. Okay, means 2, 5 will be merged with 1. Okay, and it will be form a new cluster like this. Okay, right, and after here now we have 2 cluster. Yeah, we can merge it into we will produce a new 2 clusters only here. Okay, and we need to get what will be the value here. Okay, can be done like this. Okay, and we have to draw the diagram. Okay, and then finally we update the new cluster of all objects. Yeah, and we get 0 here, so the process is terminated. Okay, so if you want to have a look at the process on the max or complete link, it start with 3, 6, and 2, 5 originally, same like mid. Okay, but the second iteration, as you see here, it will merge to other clusters, other object here. Okay, and 2, 5 will be merged with object 1. Okay, and this will be the fifth cluster. Okay, and this will be the diagram. Okay, we can have a comparison between this. Okay, so you see the dendrogram dan juga apa nama the nested cluster will be different lah, yeah, based on the methods that you apply. Yeah, so whether you apply single link mean or you apply the complete link. Okay, but again the rule of thumb, you need to merge, yeah, merge objects or cluster which is closest, give the closest value. Okay, right, so on cluster analysis, actually we are looking at the similarity and dissimilarity, and the important part is that we look at the data type. It's very important to understand that the similarity of the objects is depending on the data type, the functions or the formula. Yeah, we need to look at whether it's nominal, binary, ordinal, numeric, or textual, or it could be other as well. Okay, and then it has 2 methods in under clusterings, yeah, partitioning and also hierarchical for this subject only. But if you look at algorithm literature, there are many other subjects like SOM and so forth. Yeah, so in this subject we introduce the basic one, which is k-means and also hierarchical, but also in hierarchical I introducing you the 2 concept, which is single and also complete. Okay, ada banyak lagi kan? What are average, centroid, functions, and so forth. So we apply or we look at the single and also complete link only. Okay, so that will be the important point in clustering. Yeah. I think that I could have the exercises for you to have to do. Yeah, dalam new future ada exercise, other exercises that related to single and complete link. Yeah, for you to do to apa nama to familiarize the process. Any questions that you want to ask?
Madam,
Ya, adik.
just nak confirm, maksudnya masa first time buat Dissimilarity Matrix tu ambil dua yang lowest kan?
Ya, betul.
Lowest distance. Lepas tu the next Dissimilarity Matrix tu ambil satu je. Macam tu.
Ya, betul.
Oh, okay. Okay, thank you madam.
Any more?
Tak ada kot, madam.
Tak ada. Boleh ya? Faham?
InsyaAllah ke.
Yang lain-lain? Fatin? Fatin? Marina? Okey ke?
Okey. Okey je.
Okey je, tak promising pun jawab jawapan.
Okey.
Okay. So I hope that you boleh cuba juga Not for me, Madia. No from me. Apa tu? Oh, ni tadi ke? No question. Okay, thank you. Technically kita tak boleh nak access our system sekarang ya. Not sure what's the problem with UITM punya access ya. So saya akan ambil attendance daripada sini sahajalah ya. Show participant. So untuk WK kejap kita ada masa 10 minit sekejap je. So saya akan demo sedikit lah untuk WK kalau you tak ada questions ya. Depan ni ada kelas ke?
Ada.
Semalam ada kelas juga ke tak ada kelas semua? Ya, semalam cuti betul. Okay, let me have a look at this one. Okay. This is the flip tutorial that lab exercises that are given to you just want to share a little bit on this week or clustering in WICA lah ya. Sekejap saja. But in case you want to leave, it's okay, no problem. Kalau ada sesiapa yang nak leave pun tak ada masalah. Okay. Mana saya punya window? Okay. Boleh nampak window saya sekarang? Boleh nampak
Boleh madam.
Okay, so sekarang ni apa yang kita boleh buat dalam WK for clustering. If you look at the clustering, choose here. Okay, so you can use simple k-means and also you can do what we call just now that discussed today is clustering. Yeah, hierarchical clustering. If you look at k-means here, yeah, apa kita okay, firstly what we can do is purely on the methods of supervised unsupervised, yeah. So we assume we do not put into what we call we do not choose this one lah, yeah, because we want to do purely supervised unsupervised methods. Okay, if you look at, alamak, saya punya memory dah. Okay, nampak nampak ke saya punya setting here? Okay, nampak setting saya? Okay, so here yang paling penting dalam clustering algorithm is that to choose the distance here. Okay, whether you are using Euclidean distance ke, filtered distance, Minkowski's or Manhattan and so forth. So imagine that we are using Euclidean distance. Okay, and remember in clustering, if you use k-means, yeah, if you want to use k-means ni, data must be ni numeric. Okay. Kalau tak nanti dia akan tukar kepada mode lah. Yeah. Indirectly it will change into mode. Okay, here also if you look at your the important point, the important setting would be this part. Ya, ini iaitu maximum iteration and how many number of clusters that you want to form. Okay, so as I said that if you look at k-means, we can set or we can assign several number of cluster. Firstly, we can set into 2, we can and then later on we update into 3, 4, 5 and so forth. Okay, so for example, we start with true and then you click OK and then you click start. So this is the outcome of the cluster being produced from the data set. Okay, cluster 0, this is the centroid. So we have 1, 2, 3, 4. 4 attributes, and this is the mean of the the mean the average of the clusters for each attributes, and then this will be the average, average value of each of the variables, and as you see here, cluster 0 and cluster 1, and normally majority of the cluster 0 is belong to versicolor, and then cluster 1 is belongs to versicolor. Okay, and this will be other data that can be gained from the results from the outcome, from the k-means. Then we can visualize the clusters. Yeah, so we can visualize it based on the instances, and then this can be visualized into the cluster being produced. So we have 2 clusters here. Yeah, saya memory dah slow sangat ini sebab saya terlalu banyak buka apps, ya. So here is you see, nampak ke visualize cluster ni ke tak nampak? Sebab saya choose window. Nampak ke? Can you see the window ni? Boleh nampak ke? Tak nampak. Tapi actually technically what you can do is that you go to your result, right hand click, and then you can click apa dia? Di sini visualize cluster assignments. Okay, so ini adalah untuk k-means. Then probably you need to try update ataupun increase the number of cluster here. Yeah, so you change it into 3, says that 3, okay, and so forth. Okay. Then you can rerun and then have a look at a new, just now if you look at here, versicolor arisatosa, and then now you could see what will be the new form of 3 cluster. Okay, another methods will be the clusterer. If you look at the clusterer, okay, saya run saja ini. Right. So ini adalah untuk hierarchical clustering kita, So from WK you can see the produce what we call hierarchical cluster, yeah, and and this will be different compared to the methods of k-means just now. Okay, so another thing that we can do in Weka is that we can make we can apply clusters for classification purpose. Okay. So in order to apply it, you might need to change it into clusters to cluster evaluation. Okay, so you have to tick to this one. Okay, so yang ini nanti apa yang algorithm buat, dia akan automatically map kepada 3 clusters, and you could see here the coefficient matrix produced. Oh sorry, yang ini kena buat 3 lah. So we have 3. That's one. Okay, you have to change it from 2 to 3 lah. Okay, so briefly, that is how you can use Weka for clustering analysis. Both can be done, k-means and also hierarchical in Weka. You could probably later on explore further lah on that. Okay, kalau tak ada apa-apa soalan, you may leave. So we are going to meet next week. Saya tak boleh nak set dalam future. Okay, saya akan ambil attendance daripada daripada participation sajalah.
Thank you, Doktor.